Okay, and this is called Boolean difference. Okay, now the Boolean difference is given by this formula f, given that the input you are considering is set to 0, XOR f, given that the input you are considering is set to 1, right? If you do this XOR, you should get 1. That's the concept behind Boolean difference. Now, the reasoning is that if you test your original circuit and your wrong circuit, right, though the outputs will always be different, right? This one will output, if this one outputs 0, this one will output a 1. If this one outputs a 1, this one will output a 0. The faulty circuit and the original circuit cannot give the same results, right? So we are using that sense to, yes. Now, when you consider it says determine the text vectors for a stuck at 0. So you are here, a stuck at 0. Okay. Now, what you have to do first with the Boolean difference is that first write the circuit as the Boolean function. Okay. So that's what you are supposed to do. So f is equal to, now here is what, x1, right, and a bar, or x2 bar, right? So x1 multiplying x2 bar, right, or end, so NAND, sorry, then feeding into an OR gate, exclusive OR gate, right, and that OR gate has as an input x2 bar and x3. So x2 bar and x3, right, x2 bar and x3, right, so they are being fed into an NAND gate. Okay, then all of this is fed into the AND gate with what, this XOR function. So x3 XOR XOR x4, so x3 XOR x4, yes, it does it. Okay, so that's the whole function. Now, so that we are able to test effectively, realize that a is just x2 bar. So anywhere we see x2 bar in this equation, let's put a. Okay, so that we test effectively. So f is equal to x multiplying a. So this is x1. Okay, so here's x1. There has to be 1 here. There has to be 1 here. Right? All bar plus, here is also a because it's x2 bar. x3 all bar, x3 xor x4 all bar. Okay, so once you're able to represent it like this, then you can start. So f when x is equal to 0, when a is equal to 0, because you are doing for a. So when a is equal to 0, what will this function be? That's what you are finding. Okay, so when a is equal to 0, I don't want to write 20, but let's do it. When a is equal to 0, you realize that here will become what, x1 times 0, right? x1 multiplying 0, right? So we need the bar be 0, so inverting it to be 1. Okay, now 1 here, so 1 for, let me use the red, 1 for everything here, right? Or anything here, we don't consider it. Okay, yeah, so it means that the results of this whole expression will go to 1, right? And when you invert it, you get a 0. Now, we don't also have to consider the next step because this is a 0 and it is ending with whatever here. So it means that all here will go towards 0. Okay, so I mean whatever will come there would have been 0. Okay, so that you be fast. Okay, but you could have written it in detail, step by step. Now let's do for a equals to 1, right? So if a is equal to 1, then in the first bracket, so let me remove the reds if I can. So in the first bracket, you realize that you get what, x1 bar, x1 bar here, right? Because x1 and a will give you x1, and there is bar at the top, so you just put it there. Then 1 and x3 will just give you x3, so x3, so plus, right? And there's a one big bar at the top, so all bar, multiplying x3 xor x4, so x3 xor x4. Okay, now this is for when a is equal to 1. Now when you finish, what you are left is that they said after you've put a is equal to 0 and a is equal to 1, come and xor the two, right? So we are come to xor this one and all of this, right? But so that you don't disturb yourself, right, there is a shortcut about xor. When one of them is 0, then the result will just be the second one. So when you have maybe 0 xor a, maybe b, right, the answer is just b. Okay, so don't worry yourself. But I mean, if it was probably if it was 1, then it would just be b bar, right? So if here was another expression, that means you have to go through the step of xor bar. Because here is 0, we don't have to suffer for those steps. Okay, so it means that we can just put or you let's do it. Okay, so we can when we do an xor, right, it means I will have to do f of a when is equal to 0, right, multiplying f of a when is equal to 1 all bar plus f of a when is equal to 0 multiplying f of a when is equal to 1. So the bar would reverse. So this is for the xor. Okay, now you can just watch with your eyes and realize that when you put 0 here, right, all this function will go to 0. And when you put 0 here, this function will go to 1 and to be left with this one, which is actually for this. So our old procedure is okay. So now let's continue. So it means we know that at the end of the day, when we xor, we'll get the same function here. Okay. Then our next step is that our xor, so this one, right, is our result of our xor, which is what? x1 all bar plus x3 all bar x1. Let me expand this xor. x4 bar x3 bar x4. I've expanded the xor. Okay. Right. Now this whole thing should be equal to 1, right, according to the dictate of Boolean difference. So if this whole thing is equal to 1, how do you make this whole thing 1? Well, this is an AND gate. This one is multiplying this, so it's an AND gate, right? So it means that first, just tackle here, make sure that this one goes to 1. How can you make this one 1? So just keep your attention on this one. Well, to make this one 1, either x1 is equal to 0, right, such that it will be 1, or x1 is equal to 0 and anything for x3. Wait, no. Yeah, there's another bar there, so you have to take your time. You have to make sure that whatever comes here is what 0. Okay, yeah, so that's what you have to make sure that, because there's also a second bar, you have to make sure that whatever comes beneath here is 0, so that you get a 1 at the end of the day. So to make here 0, right, and to get a 0 at the denominator, beneath the bar, here has to be 0, here has to be 0, right? So to get 0 for x1, then x1 must be 1, because it's inverted, so x1 must be 1, right? And x3 must be what? 0, right? That is settled. Now you can do the same thing for here, right? But for here, to get a 1, if x3 is 1, x4 must be 0, and if x3 is 0, x4 must be what? 1, to be able to get a 1, right? So you realize that at the end of the day, our test vector for x1, x3, x4, right, will be 1, 1, 0, right? But so our test vector x1, x2, x3, x4, right? That's our test vector. Now x1 is what? 1, right? But what about x2? Well, you realize that x2 was what? A bar. Do you realize it? x2 was a bar. I mean, at the beginning, realize that x2 was a bar, right? And we were testing for a stuck at 0. So it means that here has to be 1, which means that x2 has to be what? 0. Okay. So it means that x2 has to be 0. Now x3 is 0 according to this one. And x4, okay, yes, yes, x3 is 0 according to this one. And x4 is what? Um, when x3 is 0, x4 must be 1. Okay, do you get it? Yes, so that's the Boolean difference. All you have to do is, once you have implemented those functions, right, expanded them, just make sure that the combination sum up. Now I realize that I didn't do for the second case where x3 is 0, sorry, x3 is 1, right, because it will conflict with here, which says that what x3 must be 0. Okay, so just take notes, and it's not very different from the other ones.